Hi, welcome back to another tutorial. My name is Martin Skelton, and today we're working on sheet metal practice. In the last few tutorials I had done, we had looked at the Jog Feature, Hem Feature, Flange, Tab, and the different Solidworks sheet metal features. Today we're looking at the end of a cable tray. I happened to come across the end of this cable tray in a workshop build that we're doing, and it's actually got everything that we've been speaking about as a prime example over the last few videos. So it would be a very good practice exercise to show an example of each of these features. I'll put the drawing on screen with the measurements. The one thing to remember is everyone uses SolidWorks in a different way, so there's no one really to say what's right and what's wrong. Looking at that drawing, I can see maybe 3 or 4 different ways that you could produce the very same flat pattern and the very same technical drawing. The way I'm going to show you is probably the fastest way that I would use the software to produce that object. We're on SolidWorks 2022. We're using millimeters as our measurement, and we're starting off with a base part. You don't have to always start in the top plane. It just always depends on the position that you want your final object, especially in something like an isometric view. If you have an object that you want to sit on the ground or a tabletop, you would draw it usually on the top plane. If you have an object that you want front and side views, then you'd use your other 2 planes. But we'll start off with the top plane. I'll show you how to change the views as well. So we're going top plane, sketch, line. Top plane for an isometric is usually the best one, and that's why most SolidWorks users start on the top plane. Top plane, sketch. Draw a line, make sure it's through your origin. Click that line, right click, select midpoint, select your origin, coincident. Then the drawing comes up, comes across, horizontal. If you go to move your line again, after you click, go back, you can see you'll start forming an arc and close out your line. We also need a center line from that origin because we're going to mirror our component across. So if we go back and look at the drawing, we have 25 millimeters outside, say 25. From here to the top of the arc is 10 millimeters. Made it small. And from this line, its thickness is 2.6 millimeters. And then we want the length of this line is 4.5. Now, we have blue line here and blue line here because we have no defined length. So on our drawing, we have a defined length of 149.28. Now, everything is black, except this point here. Now, this point doesn't matter, but just to tie it in, because that line can be any length, it's not really relevant what length it is, we just need it as our mirror point. But if we bring it down, drag and bring it down, when it lines up there, we let go, it's blue, but we know it's in line with this, so we click this line, click our blue point, coincident. Now our blue point turns black. Okay, so we want to mirror this around. Go to mirror entities. I always select what I'm mirroring around first, and then we need our entities. So we're saying this line, you can see it arrives over here. Next one, the arc and the baseline. And we click go for mirror. So now there is our sketch. We go to sheet metal. We want to make the whole thing a base flange tab. Leave our sketch open and click. Now you can see we turn it to a base flange tab, but our measurements are the outside measurements. So we start off here. We say our thickness is 0.75 for our material thickness. Our radius is 1 mil. But if you look, our material is on the outside. We need our material to be on the inside. Reverse direction. Now the material is on the inside because our 25 mil was an OD. We need a depth. So I would usually, all depends the context of what's required, but I'd usually click a midplane. And on our midplane, we know that the length of the section we require is 151.5. That is our midplane length. Click. Now we have the tray. And we click again. We have our base flange tab. We also have an edge flange, second edge flange, and a hem. Instead of doing each individual one, we have done it in one sketch that's a flat extrude. If we click flatten, you see the extrude has all its bent lines in it. That isn't an extrude, it's base flange tab. If we refer back to our drawing, we know we have two jogs, one on either side, and a center jog, and then we have cutouts all around this section. So we'll start off with doing the jog, the side jogs. So we'll actually use the top here. Click, file, sketch. Click here. Join our tab. We know our tab from our sketch is 20 millimeters. We know it is 25 in length. And we want it centered. So we click, select midpoint, hold your shift key, click, select midpoint, and then you're making concurrent. And we close. On our drawing, we have 5 millimeter tabs this side. So you click, 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 and click. And that gives us our tab. On our tab, we have some set of base holes. So we click off our fillet sketch. And we want the center of this component to here. And we have rectangles, connection rectangles. So you go center, rectangle, click. We know that rectangle is 9.1. We know it is 6.5. And the depth is the same as the front, which we have registered as 4.11. That is our tab. Click good. Back to our sheet metal. Base flange tab. Merge result. Make sure merge result is ticked. You also check your direction because you might have the reverse direction, but since we drew it on the right side, it is perfect. And we click go. There is our tab. So we need the same tab on the opposite side. We go to features, mirror. Since we started our drawing in our center, you can now go right plane, features to mirror is tab. Close. Tab on both sides. Okay, so we start now with our jog. Click our face, right click, sketch. We take our line, draw from one side to the other side, close that line. We put a dimension of 0.5 because obviously for the jog feature to work, it needs to press out. Sheet metal, we're going jog. We are putting a 45-degree jog, 0.75 in thickness, and we're changing our default radius to 0.75. So this is probably a custom tool that would do something like this because you have to really push the jog to work. If it wasn't a custom tool, you'd have to leave it all at the same angle radius because you don't want to be changing your V-dies, etc. But you could get a custom tool probably just to press this small jog in one. Obviously for something like cable tray, it would be a CNC process that would push out these, or at least finish the ends of them. So our jog is on the wrong side. We need to click back. Now our jog is on the inside. Everything looks good. We click OK. There is our jog. The reason that I didn't just mirror the jog across, most of the time they just won't mirror. They might mirror a section like that. Well, actually we'll try it, but I don't think that feature will actually mirror. We will say our right plane, features to mirror, jog. This sheet metal body cannot be mirrored individually. Please try and mirror a body. So if you mirror the body, we have other issues where we'd have to use combine commands, etc. Click in normal tool, draw a line, just draw it across anywhere. Smart dimension, down to this line, and we're saying 0.5. Then we'll use our sheet metal jog feature. This is our front face. See, our jog is the wrong side, so we have to click back, and then we click off our default radius, and we point 0.75. That tightens it in nicely, and we click OK. Second jog done. So might as well finish with the jogs at this one. Click, and we want to sketch. Do the very same thing again, corner rectangle, drop it anywhere. Want to click the line on the rectangle, select midpoint, hold your shift key, highlight the bottom line, select midpoint. You see the 2 points, and you just want to click coincident, how the 2 points is together. Click off that, and according to our drawing, it is 100 millimeters long. It's 27.5 out. We have a radius of 5 mm in the corners. Click again. We want center line, drop our center line, here to here. Then we need our center rectangle, drop our center rectangle. Follow the same as the last. So we will put it as a 9.1. 0.1, and we're going to 6.5. And we know that this top line to this point is 4.11. Sheet metal, base flange tab, make sure merge is on, click. Happy enough with that. So this one comes on the inside, so we might as well draw it from the back here. File, sketch, solid line. We'll say 0.5. Close it. Sheet metal tab, jog. This is our fixed face. And we're pointing down, but don't forget to change the default radius. It just tightens it on that point. We need it on the inside. So we click back. This flips the direction. We click OK. That's your jog feature for the inside. Now, just to show you that the jog features work, if you ever want to see the sheet metal work, just click on your flat pattern. See, so we can see where the jog lines are. We can see where our fold and bend lines are. And when we click back, 90% of the time, if an object doesn't flatten, there is something wrong. There's a command locking it in. Prime example would be a bend touching a bend. So if you can flatten it and reopen that flatten, you know that your object is good. So just to finish up this then, there is some slotted holes. So we know the size of our slots, and we need some version of a pattern possibly to do it. So as I've measured from the front, we'll take the measurements from the front, sketch. So click on the front of your piece and then click sketch, draw a center line. Okay, so we have a center line. What we'll do is we lay out the slots and then we can travel through. So we'll go with our slot command. So a straight slot. So we want the straight slot. We have our 2 points at the end. Pick a random 2 points on the center line, click. We know our slot distance from outside to outside. Now select outside to outside, hold your shift key. Then let go of the shift key once you've clicked and the dimension box comes up. And we know that the width is 7. Now there's our slot, but it's undefined in space. If you look at the drawing again, from this front line here, hold your shift key, get the outer section of the radius, come back, we know that that is 40 millimeters. We know that the next slot we have, draw on the same line again, click, click, widen. We want this slot to match this slot, so we can go up to our big tick, click, click, equal slots, okay. Smart dimension, we want the outside of this one to the outside of this one. We know that distance is 73.3. Now we want one slot in the middle, So go again, click, click, out, click, click, hold shift, click. You can see it comes up here as well, click. Now 3 slots the same. Now just as a handy little side note, if you take a center line, draw it out, draw it down, draw it back, do the very same. This is just something completely random, but if you click, click, click equals, now that slot is the dead center of the other slots. Once you delete it, it disappears again. It's just if you happen to line up something, even in an assembly, if you line up something, it's very, very handy to have a general reference at times. Okay, so we want to line up this. So we click Smart Dimension, hold on the bottom, hold Shift on the bottom, click the center of the slot, and it gives you your measurement. Now, there's lots of different ways of doing this as well, but this is just one method of doing it if you're doing it fast. So you go 73.3, which is the distance between, and we want the center of our slot to be in the middle, divide by 2. Very same thing, it's just another way of doing it. Click OK. Now, we have our slots. We know that our slots are in these exact lines. We know that there's 3 slots. We want now to make a mirror, or to make a linear pattern of these slots. So you just say linear pattern, click your entities, 1, 2, 3. We know our distance from there to there is 18 millimeters. And we're also looking for the center of the slot. So 18 plus the 7 is 25. Now, that 25 we have to have because there's a slot in the middle. So we just click here, click, divide by 2, there. So that gives us our position of our slots. So if we look at our slots, we know we need 11 slots. So 1, 2, 3, 4, 5, and this is our 6th, which is our center. So yes to our pattern. We need to define this side. So we go from our center line again to here, giving this 12.5, everything turns black, everything is defined. We then go to our mirror entities command, mirror about the middle, click. Entities to mirror, drag over all them, puts them at the far side, click. Now, there's lots of different ways of doing slots, mirroring entities and linear patterns. I can at least think of another 5 ways of doing it on just this project. But just for the example of what we're trying to achieve, this is probably the best way of doing it. So we want to get rid of some of these slots. So on our drawing, we know that the front slot in the center is not there. Then we have a slot, then we have no slot, and then we have no on the end too. This one, these 2. Down here, it says for construction. Click to turn it off. That turns everything off construction. Click again, turn it back on. Now all the slots that you don't need are in construction. That's one row. Next row has a center. So we're holding the shift. We know that this one, and the end one are not required. So that's the end one here. This one, and this one. And likewise again, because there is construction line and solid line, you click it off construction at this side. Now everything is solid, click it back on, everything is now construction. And then for our last one, we know that this one, hold shift, this one, and likewise at the far side, this one are not required. Or for construction, off, closed. Then we can go sheet metal, extruded cut, link to thickness. So whatever size your sheet is, that will link that, click good, and we are there. It's the back of our section. So you can see all our tabs, everything is nicely done in it, all around. Plain carbon. Now, this is the back in an isometric. So if we want to put this as the front and turn around our isometric, click on the back, normal 2, press spacebar. This button here, update standard views. We're saying that this is the backend object. This warning will come up. Do you want to change it? Yes. Then we go to the box, isometric view, and that shows the opposite side. If you're interested in seeing how I took this object and drew it down, and also what I'm thinking of doing with this channel, there's a video in the description that explains where I'm going with this channel and how I hand drew this. And also check out my other videos. I thank you for watching. Till the next time.